Hello everyone. In this video, you will learn concavity and inflection point. Concavity. Let f be twice differentiable on the open interval AB. If you get the second derivative a positive number, then fx is concave up. If you get the second derivative a negative number, fx is concave down. Inflection point. X equal to C is an inflection point of fx if the concavity changes at x equal to C. So for example, if you have concave up like this and then concave down, so this is the inflection point. Example: determine the intervals where the following functions are concave up or down. A. Fx equal to x squared minus 4x plus 3. First, we find the first derivative. F prime x equal to 2x minus 4. Next, we find the second derivative. F double prime x is equal to 2. Since the second derivative is a number and this number is a positive number, it means that f is concave up on minus infinity. Example B. Fx is equal to x cubed minus 3x plus 2. First, we need to find the first derivative. F prime x is equal to 3x squared minus 3. Next, we find the second derivative. F double prime x is equal to 6x. 6x is equal to 0, so x is equal to 0. Now, we draw the table. We only have one value, which is 0. So f double prime and f. When x is less than 0, for example, minus 1, substitute into the second derivative, you get 6 times minus 1 minus 6. It is a negative number. According to this table, when f, the second derivative is equal to a negative value, f is concave down. When x is greater than 0, for example, x equal to 1, substitute into x, 6 times 1 is equal to 6. It is a positive number. Refer to this table. If you have a positive number, f is concave up. So, for x less than 0, f is concave down. For x greater than 0, f is concave up. You have a changes in concavity at x equal to 0. Hence, we have an inflection point. At x equal to 0. Example C. fx is equal to x minus 1 over x plus 2. This is a rational function. Find the first derivative. One is u, one is v. We use quotient rule. So f prime x is equal to v u prime minus u v prime over v square. So this is equal to v is x plus 2. The derivative of x minus 1 is 1 minus x minus 1 times the derivative of x minus 2 is also 1. We divide everything by x plus 2 square. This is equal to x minus x 0, 2 minus minus 1, 3 over x plus 2 square. Next, we need to find the second derivative. F double prime x is equal to, in order for us to find the second derivative, it is easier if we put this one as 3x plus 2 power minus 2. So we will get minus 2 times 3, we have minus 6, x plus 2, minus 2 minus 1 is minus 3, and then we differentiate the inner function. Differentiate x, we get 1, differentiate 2, we get 0. So this is equal to 1. So the second derivative is equal to minus 6 over x plus 2 cube. From here, x plus 2 cannot be 0, or otherwise this second derivative is undefined. So x is equal to minus 2. Hence, we have, now we draw the table. Only one value, minus 2, and then we have f double prime and f. Choose a number that is less than minus 2, for example minus 3, substitute into the second derivative. Minus 3 plus 2 is minus 1. Minus 1 cube is equal to minus 1. Minus 1 times minus is positive. So in here you have a positive number. So f is concave up for x less than minus 2. Now we have to check for x greater than minus 2. For example, x equal to 0. I choose 0 because it is easier for us to calculate. Substitute 0 into x, we have 0 plus 2 equal to 2. Power 3, you get 8. Minus 6 over 8 is a negative number. Therefore, for x greater than minus 2, the function is concave down. You have a changes in concavity. For x less than minus 2, the function is concave up. For x greater than minus 2, the function is concave down. Even though you have a changes in concavity at x equal to minus 2, but x equal to minus 2 is not an inflection point because the function itself does not exist when x equal to minus 2. Thank you.